In the video on arrays, I talked about how arrays are really nothing more than lists. Each array can hold an unlimited number of a certain kind of data type. You can have a list of integers, a list of floats, a list of colors, a list of booleans, a list of characters, whatever you want your list to contain. But every element in the list is of the same type. As an analogy to an array or a list of values, imagine that you had a whole bunch of books. Books are going to be our values, and we want to line them up in order. We're going to put them on bookshelves. So we need to create a bookshelf. And in this analogy, our bookshelf is our array, and the books are the objects in the array. Suppose that you've chosen for your bookshelf a bookshelf that you buy in pieces and have to assemble yourself. So the first thing you do is you go down to the store and you buy yourself a cardboard box full of pieces. That's step one. So you bring home this cardboard box, and of course there's no bookshelf yet. There's nowhere to put your books, but you have the starting pieces. And now you do step two. You assemble the pieces into the shelf. Now you've done steps 1 and 2. You're ready for step 3. Now that you have the bookshelf, you can put your books into it. When these 3 steps are done, you've taken your unorganized mess of objects, in this case books, and you've created a nice organization from them. So that's our metaphor. We have to go through these 3 steps of obtain the parts, put them together, and then fill them in. So let's see how this works with arrays. First thing we do is we declare the array. We tell processing, I am going to create an array and I'm going to give it a name, just like I give a name to a variable. And I'm going to tell processing what kind of object it holds. So I might say I'm creating a list of integers or a list of colors or a list of floats, and here's its name. Once we've declared the array, we have to allocate memory for it. This is the equivalent of building it. Once we've declared it, all we have is a name. We don't have the array yet. We have to build it, and that's step 2. Once we've built it, then we fill in the values or we put the books on our bookshelf. As I said before, these 3 steps have kind of a quirky notation. It's not that hard, it's just a little bit different than what we've seen before. So I'll show you the notation, and rather than try to get into all the details of why it makes sense, I'll just show you what it is, and you can just use pattern matching. You can just use copy and paste for a while until you get these things under your fingertips. So let's start at step 1, declare the array. I'm going to show you how to declare an array of integers, and you do it like this. This looks very much like declaring a variable. It's a variable of type int, and its name is xpos, and I've given it a capital letter because I'm pretending it's a global variable. Arrays are often globals, not always, but for this example, I'm going to use a capital letter. The way you tell processing, this isn't just a single number, this is a list of numbers, is you put a pair of square brackets immediately after the type of the object. So here I have int bracket bracket space xpos. It's very important that you use square brackets. The curly braces or parentheses or angle brackets, they don't do the job. You want int square bracket, open close, space, the name of your list. This tells processing, I want to create a list that will hold integers. Now we don't have the memory for it yet. We haven't done step 2, so it doesn't exist yet, but we've told processing this is what it's going to be. There will be a variable called xpos, and it will hold a list of integers. Suppose we want a list of floats. Well, we just say float bracket bracket, and then the name. In this case, I'll call it radius. And this holds for any kind of variable. We can make a list of booleans if we want. We say boolean bracket bracket, and then the name of the array. And here I'm going to use a lowercase letter just to show you it can be done. So this is step 1. We declare the array. We're simply telling processing that these words represent the name of a list of objects, and we tell it what kind of object goes in there. Now it's time for step 2, to allocate the memory or build the array. And this has its own slightly weird syntax, and it looks like this. We say xpos, and that's our first example up above. So we've already declared xpos. We know it's a list of integers. followed by an equal sign, and then this weird little bit of construction. The word new, N-E-W, and that's a keyword, you have to write it just like that, followed by a space, then int, open square bracket, 3, close square bracket, and a semicolon at the end. All right, let's pull this apart. New is a keyword, and we'll see it's used in a couple of different places, but for right now, you don't even need to think about why it's there. Just remember that is part of the template. That is part of the blueprint for creating an array. First comes the word new. After the word new, we have the type of the object. And in this case, it's a list of integers. So we say int, followed by an open square bracket and the length of the array, how many entries we want processing to create for us. Then a closed square bracket and the semicolon. So this line tells processing, take xpos, which we've already declared, and actually build it. Go out there, get enough memory to hold 3 integers, and stick that into xpos. And if you write it just this way, you will get a new object called xpos that is big enough and ready to hold 3 integers. So let's see how we would build radius. Well, we can see up above, radius is a list of floats. So suppose we want to make a list of 130 floats. We'd say radius equals the keyword new, space, the word float, so it knows what kind we're making, open square bracket, and the number of elements we want, in this case, 130 of them. Then the closed square bracket and the semicolon. There we go. Processing will build that object for us. And now we're ready to stick stuff into radius. How about our third example from the top, visible? That's an array of booleans. So to create that, we say visible equals new space, the type of the object, boolean, open square bracket, and I'm going to say I want 12 of them. Close square bracket, semicolon. We'll see later that you can make the arrays longer and shorter over time. So these are just the starting size. So okay, at the end of step 2 now, we have created the array. Now we're going to fill it in with values. We're going to put numbers into the array. So how do we tell the computer that, say, the third entry in xpos, our list of integers, should be 15? This is how we write it. We say xpos, open square bracket, 2, close square bracket, equals 15. That tells it entry number 2 in the array xpos has the value 15. How about radius? Well, radius has 130 entries. So let's say that entry number 55 should have the value 34.86. So okay, we just say radius open square bracket 55 close square bracket equals 34.86. How about visible? Well, visible is a boolean. We can see we've just made 12 of them. So I can say that entry 8 in the array visible should have the value true. We could have also set it to false. Now you'll probably notice that all the lines on the right-hand side have square brackets in them. That's what the square bracket means almost everywhere in processing. It means we're doing something involving an array. To recap, you declare your array just like you would declare any variable, but then there's the extra step, step 2. You gotta do it. Don't forget to do this. If you forget, you'll get an error. So processing will remind you. You have to do the allocation step with the new and the type of the variable and then the number you want. That is required for arrays. But you only need to do that once. And once that's done, you're good. And from then on, you can just talk about the elements of the array as illustrated in step 3. There's one funny little quirk to all of this, and it has to do with where we start counting the entries in the array. Here's an array of 6 elements, and let's pretend it's an array of integers. We need to number them so we can talk about them, and so you might think we would work our way left to right and number them 1 through 6, and that would be an entirely reasonable thing to expect. And that's the quirk, because we don't do it that way. For historical reasons, these things are numbered starting with 0. So if there are 6 entries, the entries are numbered 0, 1, 2, 3, 4, 5. This has some nice advantages. It means ultimately when we're writing loops and things, it's very convenient, but it could have been done a different way. When people were first developing programming languages, they could have set it in stone and said these things begin with 1, and we would all begin with 1, but they didn't. They set it in stone that we'll all begin with 0. And from then on, every programming language basically says when we create an array, the arrays begin with element 0. Now, some languages actually let you choose. They let you say, no, I want to begin with 1. But that almost always leads to confusion because everyone expects them to begin with 0. So it's just one of those things, and it's something to keep in mind. Again, if you forget this, your program will either act a little bit funny, or it might even crash, and then you'll figure it out, and you'll say, oh man, I have to start at 0, not 1. So to illustrate this, remember the way we refer to any one of these entries. Suppose that this is our array of radius values. So we say radius, open bracket, I, close bracket. And that tells us which of these we're picking based on the value of I. So the leftmost one is radius bracket 0 bracket. Then radius bracket 1, close bracket, radius 2, 3, 4, and 5. There is no radius bracket 6 bracket because the list is only 6 elements long. And that means, starting with 0, we have entries 0, 1, 2, 3, 4, 5. Now we can put numbers into these 6 entries, and in this case they're integers, and we stick integers in them and we're good to go. In part 2, we'll continue to look at arrays, how to create them, and how to fill them in with values.